Okay, so here's the walkthrough of the Unit 1 practice test. First questions, record the measurement below to the appropriate number of decimal places. We're going to take a look down here at this item, and it looks like the edge of the box is right there. So we have 11 and 12 centimeters, which means that each mark in between is a 0.1. So we have 11.1, 2, 3, 4, 5, 6. It's between 11.6 and 11.7. So we're going to call that 11.64 centimeters. You always want to estimate in between the two marks. You could say almost anything between 11.6 and 11.7, but it would have to be 11.60, 11.61, and so on. Same type of question, and in this one we have, again, centimeters, and we have a mark that's in between what would be 1.2 and 1.3. This is 1.1, 1.2, 1.3. So we would call that 1.23 centimeters. And again, you might call it 1.24, and that would be okay as long as you have that one extra digit past the 1.2. What is the volume of the object in the graduated cylinder? So what you need to look at is that it started out with the line right here on what looks like the 32. So we're going to call that 32.0 milliliters with just the water. Once you add the fish in, it goes up from 32 to 38.0 milliliters. So to find the volume of the fish, we find the difference between where we started and where we ended up. So we would do 38.0 minus 36.0, and we get, 32.0, and we get a volume of 6.0 milliliters for the fish. And you do want to include that 0.0 because we're estimating that this water here is right on the line for 32 and right on the line for 38, so you have to include that extra 0. Second part of the question is, if we have 6.0 milliliters as the volume and we're given now 5.6 as the mass, we need to find the density. The density is equal to the mass divided by the volume, so we can plug in density equals 5.6 grams divided by 6.0 liters, milliliters. And when we do that out, we get something equal to 0.93 grams per milliliter. And I want to keep it at 0.93 because both of those numbers have two significant figures, so I want my answer to have the two significant figures. Anything else after that gets rounded off. Which prefix in the metric system means 100 times smaller? Well, the ones you need to know, okay, kilo means 1,000 times greater than the base unit, and then there's base unit. Centi means 100 times smaller, which is the answer to this question, so 0.01. And then milli is 1,000 times smaller, 0.001. So you are responsible for knowing those prefixes, kilo, centi, milli, and then obviously the base unit is equal to 1. So the answer there, was 0.01 centi. What is the name of the temperature scale in the international system? It is called Kelvin. That is the name of the scale. We don't use Celsius or Fahrenheit in reporting our measurements. We would use Celsius because that's what the thermometers have, but we always convert to this system called Kelvin. And to do that, Kelvin equals Celsius plus 273, which is going to come up here in just a minute. Water boils, and I think that's a typo in your packets. But the question says it doesn't really matter. Water at 100 degrees Celsius, what is the same temperature in Kelvin? Well, we would take 100 plus 273, and that gives us a temperature of 373 Kelvin, which is B here. Which of the following explains why styrofoam floats in water? Well, whether something floats or sinks in anything, air, water, ethanol, motor oil, okay, has to do with the relative density of the two things. Anything that is more dense than the fluid you put it in will sink. Anything that is less dense than the fluid will float. So that's why helium balloons float in the air, because a helium balloon is less dense than the air around it, so it floats. So that tells us that the styrofoam, if it floats, must be less dense than the water it's floating in. Which of these has a low density? And this is obviously relative because you're not given any information to calculate the actual densities. But if you just think in terms of which would be the lowest of these four things, the easiest thing to think about is what happens to this stuff if you put it in water. So rocks would sink, lead sinks, iron sinks, wood floats, therefore wood must have the lowest density of those things because everything else is more dense than water. What is the density of a block of metal with a volume of, that should say a mass of, that was another typo, sorry about that. Okay, mass of 25 grams and a volume. So again, density equals mass over volume. So density equals 25 grams over 50 milliliters. Grams is always mass, milliliters or cubic centimeters. That would look like this. That's volume always, so you can kind of figure out which goes where. When you do that out, you get 0.5 grams per milliliter. That's the unit for density. It's mass over volume. So it could be any other thing. It could be kilograms over cubic meters or whatever, but in this case we were given grams and milliliters, so that's our unit. Convert 2 meters to kilometers. Well, you need to know how many meters there are in 1 kilometer. 2 meters, 1 kilometer, we're trying to convert to kilometers, so that's going to go on top. 1 kilometer, we saw this a couple slides ago, kilo means 1,000 base units, meters is the base unit. So 1 kilometer is equal to 1,000 base units, which means 2 meters times 1 over 1,000, which is the same as 2 divided by 1,000, equals 0.002 kilometers. If a block of gold has this density and this volume, what is its mass? Okay, so we're back to the density equation, which is mass over volume. But this time we're not given the mass and the volume to find the density, we're given the density and the volume to find the mass. So you need to remember this little triangle. Okay, the mass is always going to be on top if you're given that, and then you would put the density or the volume under the mass if you were trying to do that. In this case, we've got density and we've got volume. Since they're side by side in the triangle, what that means is we multiply them together to find the mass. So 19.3 times 27.5 gives me a mass of 531 grams. Okay, what is your percent error? And we don't know how much we did on this formula. I will give you this formula. I will give you the density formula for that matter on the test. You just need to know what to do with it. But to find percent error, which is this up here, you're trying to figure out how far off your answer was from the correct answer and then give that in a percent. So this is kind of the opposite of calculating your score on a test, or it would be backwards from that. Usually you try to figure out how many points you got out of the 100% possible. This would be like saying, well, what percent did I get wrong? You know, if I missed 4 questions out of 27 questions, what's my percent error? How many did I get wrong? So what you need to do is take the measurement that you got, which we said was 0.1, subtract the correct answer, which is 0.07, and then divide it by the correct answer. Again, this is kind of like what you do on a test. You take the number of points that you missed, in this case, and divide it by the total possible points, and that'll tell you the percent you got wrong, and then you have to multiply it by 100 to make it a percentage. And when you do that out, you get 42.857%, which, since these are both one-digit numbers, we can round that to 40%. Okay, which of these are chemical or physical changes? So melting or boiling or freezing is always physical. Rust, okay, rust, combustion, burning stuff, that's going to be always chemical. Anytime you're changing the appearance, like tearing it into pieces or crushing it or crumpling it or anything like that, that's only a physical change. You're not altering the stuff. Boiling water is just turning liquid water into gas, still water. So that's physical. Freezing, boiling, melting, all physical. And then cooking an egg, you're changing the composition of the egg, which means that's a chemical change. Okay, what is the difference between intensive and extensive? I'm not going to write all this down, but intensive means it doesn't change depending on the amount of stuff. So it would be things like density or color, right? Something is blue whether you've got a little bit of it or a lot of it. And the density of aluminum is not based on how much aluminum you have, it's just a property of aluminum itself. So intensive doesn't depend on the amount of stuff you have, whereas extensive depends on the extent. It's an external kind of property, like the mass or the volume. If you change the amount of stuff, you change the mass. Right? You put more stuff on the scale, the mass goes up. You put more stuff in the graduated cylinder, the volume goes up. So those are extensive because they change depending on the amount. Okay, which of these is a compound? Remember, a compound means that it's two or more elements bonded together chemically in a consistent way. So carbon is just an element, so that's not a compound. It's an element by itself. It's on the periodic table. Water, H2O. Okay, anytime you have something that can be written as a formula with more than one capital letter, like H2O or CO2 or NaCl, like that, those all have two capital letters. You could have more than that, but anytime there's two or more, that means it's a compound. Okay, water is a compound. Soil is a mixture. Salt water is also a mixture called a solution. Which is a homogeneous mixture. Homogeneous mixture means that it's blended evenly together and you can't really tell the pieces apart, whereas heterogeneous means it's kind of jumbled together randomly, but you can still see the pieces like a salad or a scoop of dirt. But homogeneous means you can't tell it apart. Air is a homogeneous mixture. It's a bunch of gases mixed together in a fairly consistent way. There's a certain percentage of oxygen, a certain percentage of nitrogen, and percentage of argon and things like that in the air around us. There's other stuff too, but air is a mixture like that. Table salt is a compound. Pure gold is an element. Salad dressing would be an example of the heterogeneous because you can see all the bits and pieces. And if you just let it sit there, all the pieces settle to the bottom, the oil sits on the top, and it's not mixed evenly. Okay, so last question on the practice test. If a student records the following measurement for the density of aluminum and the accepted value is 2.7 grams per cubic centimeter, how would you classify these calculations? So they did this 3 times. Okay, 3 different trials. They measured the volume, measured the mass, calculated the density, and they did it 3 times, maybe with 3 different pieces of aluminum, doesn't really matter. But they did it 3 times, and they got these 3 answers. So here's the question. What does accurate mean, and what does precise mean? Accurate means you got something close to the right answer. I would say that 3.8-ish is not very close to 2.7 when you consider it's, almost half off, right? Because it's 1 whole gram per cubic centimeter off from the right answer, and the right answer is only 2.7. So that's a pretty big difference. So it's not accurate. Okay, it's definitely not accurate. Now the question is it precise? What does precise mean? Precise means you get the same answer every time. Well, they didn't get exactly the same answer, but the difference is only in the hundredth place, and it's only by a couple of hundredths either way. 8.84, 0.87, 0.85, those are pretty close. So I would say the answers are precise. They're just not accurate because they're not the right answer. They did something wrong in their calculations, but whatever they did, they did it the same way every time and they got something close to the same answer every time. Okay, so that's it. You need to study those topics. Again, you will be given the density formula and the percent error formula on the test. You will need a calculator, not your phone, an actual calculator, and something to write with. Doesn't matter if it's pen or pencil. You can use either on the test, that's fine. So there you go, the test is on Wednesday.